Hello everyone! In advance, let me introduce myself. My name is Nikada Septiani with number ID of 211301192, student from the Mathematics Department at Ganesha Education University. So, I am here to explain the material about relation and function. Function are nothing but special types of relation that define the precise correspondence between one quantity with the other. In the video, I will explain about how to link pairs of elements from two sets and then define a relation between them, different types of relation and function, and the difference between relation and function. Relation and function in real life give us the link between any two entities. In our daily life, we come across many patterns and links that characterize relations such as a relation between a father and a son, brother and sister, etc. In mathematics also we come across many relations between numbers such as a number x is less than y. Line L is parallel to line M, etc. Relation and function map elements of one set or domain to the elements of another set or codomain. What are relation and function? Relation and function define a mapping between two sets, input and output, such that they have ordered pairs of the form input-output. Relation and function are very important concepts in algebra and calculus. They are used widely in mathematics as well as in real life. Let me define each of these terms of relation and function to understand their meaning. Relation and function definition. Relation and function individually are defined as relation. A relation are from a non-empty A to a non-empty set B is a subset of the Cartesian product A multiplied by B. The subset is derived by describing a relationship between the first element and the second element of the ordered pairs in A multiplied by B. Function. A relation of form a set A to a set B is said to be a function if every element of set A has one and only one image in set B. In other words, no two distinct elements of B have the same pre-image. The following is an image diagram of relationship and function. Note, so please remember that all functions are relation, but not all relation are function. Now, I will explain about representation of relation and function. Relation and function can be represented in different forms such as a row representation, algebra form, set builder form, graphical form, roster form, and tabular form. Define a function f a equals 1, 2, 3, b equals 1, 4, 9, such that f1 equals 1, f2 equals 4, f3 equals 9. Now, let us represent this function in different forms. First, set builder forms. xy equals y equals x squared, x element A, y element B. Second, roster form. 1, 1, 2, 4, 3, 9. Third, a row representation, the result can be seen in the image. For table representation, the result can be seen in the image. Difference between relation and function. The basic difference between a relation and a function is that in a relation, a single input may have multiple outputs. But in a function, each input has a single output. The table given below highlight the difference between relation and function. Note, look at the example of the relation above. 1x, 1y, 4z. This is not a function as a single element 1 is related to multiple elements x and y. Hence, the statement every relation is a function is incorrect. Terms relate to relation and function. Now that we have understood the meaning of relation and function, let us understand the meanings of a few terms related to relation and function that will help to understand the concept in a better way. First, Cartesian product. Given two non-empty sets P and Q, the Cartesian product P multiplied by Q is the set of all ordered pairs of elements from P and Q. That is, P multiplied by Q equals PQ. Define P element P, Q element Q. Second, domain. The set of all first elements of the order pairs in a relation R from a set A to a set B is called the domain of the relation R. It is called the set of inputs or pre-image. Range. The set of all second elements of the order pairs in a relation R from a set A to a set B is called the range of the relation R. It is called the set of outputs or image. Codomain. The whole set B in a relation R from a set A to a set B is called the codomain of the relation R. Note, the range is a subset of codomain. Next, I will explain about types of relation and function. Different types of relation and function have specific properties which make them different and unique. Let us go through the list of types of relation and function given below. Types of function given below is a list of different types of function. 1. One-to-one function. A function f(a) for b is said to be one-to-one if each element of A is mapped to a distinct element of B. It is also known as injective function. 2. Onto function. A function f(a) for b is said to be onto if every element of B is the image of some elements of A under F. There exists an element A in such that f for A equals B. A function is onto if and only if the range of the function equals B. Many-to-the-one function. A many-to-one function is defined by the function f(a) for b such that more than one element of the set A are connected to the same element in the set B. Bijective function. A function that is both one-to-one and onto function is called a bijective function. Constant function. The constant function is of the form f of x equals k, where k is a real number. For the difference values of the domain or x value, the same range value of k is obtained for a constant function. Identity function. An identity function is a function where each element in a set B gives the image of itself as the same element. Thus, it is of the form g of x equal x. Algebraic functions are based on the degree of the algebraic expression. The important algebraic functions are linear function, quadratic function, cubic function, polynomial function, objective function. Now I will explain about types of relation. Given below is a list of different types of relation. Empty relation. A relation is an empty relation if it has no elements. That is, no elements of set A. Set A is mapped or linked to any elements of A. It is denoted by R equals empty set. Universal relation. A relation R in a set A is a universal relation if each element of A is related to every element of A. It is called the full relation. Identity relation. A relation R on A is said to be an identity relation if each element of A is related to itself, that is R equals A for all A, element A. Inverse relation define R to be a relation from set P to set Q. The relation R to the negative 1 is said to be an inverse relation if R to the negative 1. From set Q to P is denoted by R to the negative 1 equals QP element R. Reflexive relation. A binary relation R defined on a set A is said to be reflexive if for every element A, element A. We have A R A, that is A element R. Symmetric relation. A binary relation R defined on a set A is said to be symmetric if and only if for element A, B, element A. We have ARB, that is A, B, element R. Then we must have BRA, that is B, A, element R. Transitive relation. A relation R is transitive if and only if A, B element R and B, C element R. For EC element R, for A, B, C element A. Equivalence relation. A relation R defined on a set A is said to be an equivalence relation if and only if it is reflexive, symmetric, and transitive. Antisymmetric relation. A relation R on a set A is said to be antisymmetric if AB equal not if AB element R and BA element R for A equals B. Now, I will explain about important notes on relation and function. From all the material that we learned before, we have 3 important things that we should remember. 1. Relation and function define the relation between the elements of two sets and are represented as a set of ordered pairs. 2. Relation and function can be represented in different forms such as a row representation, algebraic form, set builder form, graph form, raster form, and tabular form. 3. And relation may not be a function, but every function is a relation. Okay, well, that's all the material that I can describe on this occasion. Now, do you understand about relation and function? Or they're all still confused? If they are still confused, you can contact me. Yes, contact below. Maybe that's all from me. Thank you to all of you who have listened and watch things video from beginning to end. I apologize profusely if I make a mistake intentionally or unintentionally. I hope the material that I describe on this occasion will be useful for all of you in the future. Once again, I thank you very much and see you soon.